Welcome to the sixth episode of Under the Hood. So in some of the previous episodes you might have seen, we talked about different things. We talked about AI, we talked about the compiler, we talked a lot about performance and how to write performance AL code. But today I have Gert with me. Hi Gert.
Hi.
And we are going to talk about our app, our base app, and also about events and componentization and all these things, right?
Yep.
So welcome Gert. Gert, please introduce yourself. So you've been working with primarily on the app side for a while. So what are you doing? What is your role in the engineering team?
So I'm an architect on the application team, and currently mainly focused on extensibility and componentization of the application, as well as other architecture-related things related to the application.
All right, cool. So you know the app very well. It's fair to say.
I hope so.
Yeah. So before we talk about componentization and event and all this, let's go a little bit back in time. We didn't always have events as a customization mechanism. We'll talk a lot more about event later, but in the earlier versions of BC and Nav, if you wanted to extend Nav, the approach was different.
Yeah. So before extensions, we had a code customization model. So our code is, I guess, semi-open source.
So mean we ship the code?
Yeah, we ship the code
product,
to all our partners. It's not open source because it's not open to the public, but it's open to our partners. And the way they extended the application was by changing the source code that we ship to them.
So to just change the line of code and just
go in, add code, change code, remove code, up to them, whatever they needed to build their features on top of ours. That was
so that's the code. That's what we refer to as code customization approach, right?
Yes.
And so we as early I think as 2016, we started introducing events as an alternative customization mechanism, right?
Yeah.
So why is code customization? Why did we want to get away from code customization? Why not stick with it and just proceed, right?
So code customization was a very successful model because it was very flexible, but it had a big downside in that whenever we changed the code and we shipped a new version, or you had to code customize across different localizations, then you had to merge the original code with the modified code. So our partners spent a lot of time merging text, basically, in these text to merge their changes into our new code, or to merge their changes into a different localization. And that's an expensive part of the code customization process. So in, I think, 2016 version 9, we introduced events. We had two types of events. So CRUD events, they're like platform raised events when you modify a record or when you open a page, and integration events. So integration events were a way of taking the code customization out of the source code. So you would subscribe to this event, which was placed where you wanted to put your code, and then when you didn't have this merge problem anymore. So that was the goal.
So one of the motivation also was at that time we were actually going to the cloud, right?
Yeah. So I think this was early in our journey to the cloud.
But the merge model, the merging code and the whole code customization is not really fitted for the cloud, right?
Yeah. So when we go to the cloud, upgrades become a very different beast, right? So before, all the upgrades were on-prem, managed by a partner who went in and did code merges, and then they had a two-step data upgrade. Whereas in the cloud, upgrades are expected to be much more frequent, but also kind of instant and automatic.
And also, major difference is that in the past, partners would take care of these upgrades.
Yeah.
And when we moved to the cloud, we had to take care of it. So in order to scale, we had to find another way for extensibility, right?
Yeah. It's also a shift in going from a bespoke solution for a given customer to a much more repeatable solution where partners can sell the same feature to many different customers without having to do all this merging work and all these
Yeah,
these
so we
upgrades.
moved to, so that's the extension model.
Yeah.
We moved from a code-based customization, code customization to extensions, which are basically a piece of code which is on top of the base app or the app we ship. Right? So at the beginning, in our app, in the code we shipped from Microsoft, there was no event at all. So we when we started with that,
Yes.
so we had to introduce this event somehow.
Yeah.
So what's the process for that? How did we go about that?
Yeah, so there's been different stages. So the very first events we introduced, the very first usage of events was for the workflow feature, which we were building at the time. So that when we were developing the workflow feature, we put events where we needed them for that feature. At the same time, we also introduced, I think it was around 300 events in the most commonly extended places. So think sales posting, journal line posting, sales posting. And those were very highly curated events. Like we knew that those places were heavily customized so that they would get great usage. But ultimately 300 is a drop in the bucket, right? So it's very little. So in order to get the events that partners needed, we asked them, which event, where do you need an event? Which events do you need? And we did that by getting them to request events on GitHub, so GitHub issues. And so we got, over the years, thousands of requests where partners needed to inject their code into ours.
So actually, most events that are in the code today have been requested by partners, right?
Yeah.
As opposed
absolutely.
to if you should compare the ones that we introduced, so Microsoft introduced, and the one that have been requested originally by partners.
Yeah, I'd say over 90% is partner requested events.
Yeah. So we had this basically community-driven approach in terms of how we made our app extensible. Right? So how many events do we have today total?
Right. I'll show you a slide that shows a little bit about the history of how these events came about. So we started in version 9. We had no events. We added a couple for workflow, and then
there were like 10 events, or you remember?
It's hard. I think in the first version we shipped like 300 events.
Okay, so we shipped a pretty large number of events in the first version.
That was good. So right now in version 25, I think we have 22,500 events. And in the first few years, the growth was almost exponential, but then it flattened out. So since version 15, I think we have linear growth. We add.
Okay, but we're still adding events.
We're still adding events, and as far as I can tell, we haven't slowed down yet.
Okay.
So, partners need a lot of events. We add a lot of these events, and.
Do you think we have too many events?
Personally, I think we have way too many events. So I have another slide that I can show that maybe explains a little bit about why. So we have 22,500 events, and for our cloud platform, we can check how many of these events are used by how many apps and how many environments.
So looking at our usage telemetry.
Looking at our usage telemetry. So we have about 3,400 events that are not used at all in the cloud.
Okay.
But nobody uses them.
We could remove them, nobody would notice?
Maybe
somebody's
some
using
partners
it
on-prem, but in the cloud, nobody would notice.
Okay.
Then you look at events that are used by single environments. So there's one customer out there that uses this event. That's another 500-600 events. And then as you look at how many events are used more and more, so 53% of events, so that's 11,000 something events, I think. My math is right. Are used in less than 100 environments. So 100 environments to our cloud environment is really almost nothing. And then if you look at under 1,000 environments, where it becomes a significant number, we're at 85%.
Okay.
So the large majority of events are used by very few people. There's also another statistic which is interesting, is that most of our code doesn't have integration events at all.
At all. Yeah.
So I think the reason we're still seeing event requests is because we have room to grow. Not in every object.
So what you're saying is that a lot of the events are concentrated actually on few objects. If you look at the number of objects we have in total, which is, what do you remember how many objects do we have?
So we have, so in total we have like 7,500 objects. I think roughly 15% of them don't contain code at all. So they also don't have events, but that's normal. And then our events are concentrated in about 1/3 of the remaining objects. And then there's 50% of the objects that could contain events don't have events at all.
Okay.
So I don't expect every object to get events, but it shows they're very highly concentrated.
But that's to be expected. These are the places where our partners need customization, right?
Yeah.
And there's some which are just, you don't want to customize, I don't know, some basic things around.
There are objects that don't need customization. There are others that need a lot. I get a little bit scared sometimes when you see these the big objects, sales posting, purchase posting.
I do have a lot of events.
They have 600 plus events
per object or something.
No, in sales posting code unit, there's like 600 events. So it becomes very difficult to know exactly which event you should use for your feature, because you could pick 25 of them and they'd probably all work. I also looked a little bit at how densely populated an object is with events, and we have objects where there is an event for every 5 lines of code.
So why is that? Why is this a problem to have many events? Because you seem to indicate that it is not a good thing.
I don't think it's a good thing. In principle, there's nothing wrong with having the events, because if you don't subscribe to them, the performance impact, things like that, should be minimal. But when we want to make even something as simple as a bug fix, right, around where these events are, or you want to refactor the code, almost every change you make in these objects becomes breaking, because you change either the context in which the event is raised, you might change some of its parameters, you might stop calling the event, the event might move somewhere else, and so
if you have an event every 5 lines of code, let's say you want to fix some bugs in some procedure or something, and if you have an event every 5 lines of code, it's become very hard to. It's kind of a minefield. You don't know where to change the code without. You need to respect the event. If you really truly want to be non-breaking, you would need to respect the order of which the events are fired and all these things, right?
So a big issue there is we are a little bit blind to what our partners do in the subscribers to these events. So we have a pretty good idea of what you could use those events for, but we don't actually know what they're doing. So even though we don't make compiler breaking changes, I mean the partner's code will still compile and run, but we introduce side effects. The behavior changes. The expectation sometimes changes.
So maybe we're a little bit too generous with events, but I think that may be a compromise to. I mean, what we wanted back then, what we wanted was to accelerate the move of our partners to the cloud. So they wanted to be able to extend BC and get to the cloud. So we had to be maybe a bit generous with how many events we implemented and gave our partners. But maybe now it's time to go back on this and do a little bit of cleanup, right?
Yeah, so I mean, it was absolutely necessary. We would not be where we are today if we had not provided all the events that our partners need. I think, yes, it is time to take a more critical look at these events. So, for example, these 3,000 plus events that are not used in the cloud, we could choose to remove those.
So we can tell our partners, right, we are going to remove some events.
Yes.
it's coming.
I think there's other situations where if you look at a little bit of code, maybe 25 lines of code, and there's 3 function calls, you get kind of like duplicate events, right? So I might have an on before I call this function event, but then inside that function, I have another on before I do this thing event. So why do we need both? Can we look at that and pick one and then have that one? Of course,
when I look at some of the names of the events we have, they're also a little bit telling, how, like it's not, some of them are called something like on before this, but after that.
Yes.
Which is a little bit, starts being a little bit suspicious, because it means that you want to do something, basically you want to intervene with your code in between some other lines of code, and it starts to resemble very much the good old code customization model, right?
Yeah, I think right now we have quite a lot of code where the events are just glorified code customization, right? If you have 1 or 2 lines of code between 2 events, we need to find better ways of handling that.
I mean, you would say ultimately, if we had an event, before and after each line of code, then we would be back to code customization, actually.
Yeah, I think so.
Which we don't have that yet, and we hopefully we never will. But
I think the real issue behind all of this is that we went away from the code merges because every time we changed our code and partners had to merge, that was essentially a breaking change for them. Whereas now we have so many events, every time we make a change, we're also breaking our partners. So we are reintroducing this workload, but in a slightly different way. It's no more text merged, but now it's, they have to rewrite their subscribers in a different way. And so that's also very painful. So one last thing that I wanted to mention about these events, because you mentioned the on before, on after. Yeah. So we tend to think of the very beginning of a procedure or the very end of a procedure as natural places to extend or to put an event to extend code, right? So on before would be the beginning, and on after would be after I did the thing. Yeah. So looking at where our events are placed in code, we very much prefer the on after. So about 1/3 of all events are at the end of a function.
Why is that? Why do you prefer the on after?
I don't know. I think it's.
When you mean we prefer that there are more events which are on after?
Yes.
Is that what you mean?
Yes.
So our partners actually prefer.
Yes.
Most. That's what you want to say, right?
Yeah. So I think it's also because you want to, as a partner, you extend a feature. You kind of think to me, okay, after Microsoft has done this bit of logic, I want to inject my logic. So at the end of the function is when that happens. Nothing wrong with that. You also might want to do something before Microsoft processes this record, I want to inject my logic. So that's fine. So with the beginning of the function, it's a little bit more spread out, but again, it's about 1/3. And then the rest of events, so that's 1/3, so that's 7,000 something events. They're really everywhere in the code. They're in the middle, and those are the ones that are hardest to handle when you refactor code, because an event at the end, you can manage, you can move it a little bit more easily. But if it's in the middle of processing a particular bit of logic, it's very tricky to refactor and not break what the event does.
So events is one mechanism of extensibility. It's not the only one. We have others, right?
Yeah.
And so what are the other?
So
let's just sum up. So how can you? So if you want to extend Business Central, when you start writing your code, you can subscribe to event. That's one thing. Right? Yeah. What else?
So the most basic ones are extensibility objects. So page extension, table extension, now report extension. They're kind of like the big
so you kind of extend an existing object.
You can add extra fields to a table, to a page. Yeah. We can extend enums now, which is very useful in the code. Interfaces are a very nice way of doing extensibility, where a partner can either come with their own implementation. If we allow them to change the default implementation, then they can bring their own. I think that's very powerful.
So would you say interfaces are a better extensibility mechanism than as events
It's
compared to events?
it depends on the situation, I think.
Mm-hmm.
But yes, I think in many cases, having an extensible enum with an interface is a better way of having the partner provide their different implementation instead of what we tend to do in many places now is what we call a handled event,
Mm-hmm.
which is you subscribe to it and you say, I want to skip this code that Microsoft did and I'm going to put in my own implementation.
Yeah.
And that's not a very friendly way of extending.
The interface are maybe a little more clear of a contract. It's a clear contract.
So an interface is a much more controlled way of doing things.
So do you see
it's
us
easier to
moving
implement.
toward in that direction, having more and more interfaces and extensible enums and less events in the future?
I think as we refactor the legacy base app code, that's where we're going. So when we look at the newer features that are being written or the areas that we componentize, we see a heavy use of interfaces. In most all the new features introduce some kind of interfaces. And we see 10 times less events. So a factor 10 less is quite important. And it's not so much because we use interfaces or because we pick one method over another. I think it's more the legacy code base was written for a code customization model. That was the purpose of it. So it was written a certain way. When we now refactor the code and we design it to be extensible, and we do it on purpose, so to say. We design the feature to be extended in a certain way through interfaces with or without events. We see that we get far fewer events, and we don't get the events that are like code customization, right? You don't get an event like between line 7 and 8.
Do something, yeah.
You get much more purposeful events, and those are much better, and they don't change as frequently. So I think that is a better model.
So talking about refactoring, let's talk a little bit about the componentization. You've been working on componentization for a while.
For a long time now.
Yeah, for a long time now. Yeah. So just give us a little bit of a summary of where we at with that, and so why are we doing this? Why is it a good thing, and what have we done so far, and where are we going with this?
Our legacy base app is filled with it's basically spaghetti code, right? It's got circular references everywhere. It's mostly very old code. Everything relies on everything else. And it's very difficult to, if you're a new developer, it's very difficult to understand why things are the way they are. It's not documented because that was not required in the past. And it's there. You can't really get an overview of it. So we've done several things to reduce the spaghetti code and turn it into more reusable building blocks. So we are taking local features and turning those into apps so that we delocalize the base application.
So that's at the top of the stack.
That's at the top of the stack.
Yeah.
That doesn't really reduce base app a lot because it's mostly in the local versions, but those are the ones our partners use, so it's not without its merit. But it doesn't do much for W1. Another thing which we did a couple of years ago was we started pulling stuff out from the bottom. So that's very early on started with splitting our 2-tier architecture into a 3-tier, right? We split the server out, and we took out code unit 1.
That was a long time ago.
Old code unit 1 went away very long time ago. But system application is the step that came after that.
Which is why we don't have a code unit 1 today.
Yes, that is true. So the system application is all of these utility type functionalities that are almost platform-like, but were built in the application.
But they don't have, so correct me if I'm wrong, but everything in a system app has nothing to do with ERP actually.
No,
It's more
it's
APIs
very,
for
it's very technical stuff.
HTTP requests, Azure Key Vault, things
User
which are
login, company open,
file I/O, all this
Yeah.
kind of thing, which don't really have anything to do with
that's
ERP, right?
that's a requirement for being in the
Yeah.
system application, is that it's non-business domain stuff.
Right.
It's stuff that everybody will need when writing almost any software program. And it's very close to the platform, so we can seal it off a bit better. And we've made the features extensible. It's also open source, truly open source now. It's on GitHub.
And it's actually a different app, like
Yes.
also physically.
Yes.
It's a different extension, right?
Yeah. And the way it's built is also different. So system application is one app, but it's actually made up of over 100 modules now, which are each individually built as an app as well. That's just not the way we ship it, but we build it and test all of them individually, and then we repackage it as one app, and that's the one that we ship.
So we actually, what you're saying, internally, we're actually building each of these modules as a separate extension, a
Yes.
separate app, as a,
Yeah.
it's only a build exercise, right? But it's
Yes.
just a way to verify that we have good separation of concern
And no
and-
circular dependencies.
and no circular dependency. So we could potentially ship them,
Yes.
but it's just a physical, it's the system app is just a physical packaging. All this,
Yeah.
it's just more convenient, right, to ship them
Absolutely.
together and version it.
Yeah.
But potentially we could ship all of these modules individually, right?
Yeah, I think the decision to not ship them individually, I think, is more of a user friendliness kind of thing. Like, who wants to manage 100 separate dependencies when it's not really needed?
And then you have this module in that version, and also from versioning standpoint, it's a little bit easier.
Yeah.
But,
So who knows? Maybe one day, that will become a thing. But so far, we get the system app. We call that a layer. So it's a nice and easy way of working in it, and we have the build system to, keep us honest, so that we don't mess up with the dependency tree. So that's very good. Recently, we added the next layer, so that I think version 24, which we shipped 6 months ago. We added Business Foundation.
So you've been working a lot on that part.
As well. So that is now the first time where we're getting into the business domain. So the rule, so where a system application is, no business domain, Business Foundation is meant to be the foundational layer. So the rule there is there are features that apply to none of the domains, but they're still business-like, or all of them. So it's
it is ERP related. But it's not.
It's not finance specific.
It's not finance. It's not inventory. It's not service management.
Exactly.
But it is as opposed to system app. You wouldn't find that type of implementation in a non-ERP software. So what are examples of things in the business foundation layer?
So right now we have number series and audit codes, so kind of for audit trail. Other candidates would be things like dimensions, which it is a finance feature, but it's used basically everywhere.
So the work there would be, so that maybe let's assume that's our next step, right? So the work would be pulling everything that has to do with dimensions, which today is in the base app, right? And put it in factoring it out into the business foundation, right?
There's a couple of steps into doing that. So what would go in the business foundation is really the core of dimensions, right? So think setups, actually the tables holding the dimensions, some of the basic logic around dimensions, which you can, which combinations of dimensions you can use, those kind of things. Because every other feature in BC would use that module. and they might add features to it, or they might extend it, or they might use it in a slightly different way. But the core of it, that would go into Business Foundation. And then everything else now becomes a user of that module. So that's I think number series is a good way to see what that means. When we build these modules, we actually rewrite most of the code. So we don't just blindly take a feature, copy paste it somewhat, and then say, all right, now we made a module. We go in and we try and rewrite the code with modern tools, maybe fix some issues that were in the original design, improve the feature if we see things that don't really work the way we like. So yeah, a lot of work goes in. Also very important, we document everything. That the public API gets split out into separate objects, so they're easier to handle, and we document all of those.
And these documents get published also online, right? It's not only
absolutely.
so we have code comments.
Yeah, it's
documentation in the code, but it also get published on the Microsoft.
It's developer code, and it gets extracted and put in the developer section on I guess it's learning.
Yeah, we'll put some links in the description.
Yeah.
So just to summarize, so we have a bottom up approach where we take things like system app and Business Foundation and kind of put them at the bottom of the stack in like separate modules. By the way, is the Business Foundation, is that also a separate app?
Yes, it's also a layer app, so it'll be made up of different modules, but it's built and shipped with the same process as system application.
Okay.
So it's also a separate app.
It's a separate extension. So when you look at your extension overview in BC, you'll see it as a separate one. Yeah.
Yep.
And then we have a top down. You talk about localization. We have also do we also have other first party apps at the top of the stack also that we kind of remove or kind of refactor out of this app?
So we do a lot of different things at the same time. So we build a lot of new features as apps that go on top. In terms of componentizing base app, we have pulling out from the bottom, the localizations pulling out from the top, and now we're also looking at taking domains really, so service management, manufacturing, taking those features and putting those into a separate app. So that will have a big impact on the base application, because it's a lot of code that will get moved, and we're still looking into how we can make that non-breaking. And
again, this is all good because when we do that, you make sure that, for example, in this module for service management, we don't have objects which, for example, are about finance or HR or some totally other area. So that's making sure we have a good separation of concern. And also when we create new objects, then if we kind of have these modules which have a clear defined purpose and role, then we know where to put them. If you create this has to do with finance, okay, that goes there. If it goes with something with HR, okay, that goes there, right? So in the future, it's all a good way. It's good to have these structure in order to get even more structure.
Yeah. We in the past, the whole application was
one big
a set
pile.
of files.
You just put it on top. Put something new. You just put it on the top of the pile, right?
And it was very easy for the developer. You didn't have to think about any of these things. You just put it in, and that was it.
But then the part was not easy maybe for new developers to understand the app because it was so unstructured. It's still today. Yeah. It's a pretty complex app, right? And what we hope also is with this effort that we eventually, for new developers or even seasoned developers, it will be easier to navigate the app and understand where they need to it needs to be extended and what it does and all this, right?
Yeah. So we've gone through several steps, I think. So one of the first things we did was we organized our source code into separate folders. I think that was one of the first things we did. We introduced namespaces.
Yeah.
So we, even though we still have the folder structure, we added namespaces to the objects
as a language feature.
Absolutely. So now it's much easier in the code, you can instantly see, oh, it belongs to this area or that area. And this object, while belonging to finance, actually relies on these other namespaces.
And that's so. Now that we have completion and IntelliSense in Visual Studio Code, it also helps discoverability of object, right, in the namespaces, because you can go and type, Microsoft dot and then finance, for example, and then dot, and then you will see a list of objects, which is much smaller. Then before we had namespace, we also had IntelliSense and completion and all that, but you would have like a very big list of all the tables and all the, which makes it a lot more difficult to find your way around when you coding.
Yeah. Absolutely. We're doing a lot of things to help reduce the amount of code you have to sift through to understand the functionality that you're working with. There isn't a single, magic bullet that will fix all of it, but all of these together, I think, make it very useful. Also for componentization, we use namespaces to figure out where the limits of features are, and we do internal refactoring. Even though we don't extract something as a component, we're already refactoring to make the namespace cloud, less of a mess, but make it more streamlined, because that helps us later. So we're doing a lot of things in that area.
So are these changes, are they breaking?
Yes, unfortunately, many of them are.
All of them, or?
I wouldn't say all of them, but I think many of the changes that we make end up being breaking. So again, when we introduced the system application, at the same time we introduced an obsolescence scheme. So in the past, a new version would come out and partners would discover like, hey, this new stuff broke my functionality. Now I have to rework everything, and where do I start? Now that we have these obsolescence properties, we obsolete code. We give partners, I think, 12 to 18 months to uptake, so they get warnings. So if they recompile their app, they can see like, oh, this is going to be a problem.
The code is still there.
Yeah. And then after 18 months, we actually remove the old code. And at that point, it does become breaking. We have very strict guidelines around this. We do try to avoid major breaking changes. We provide obsolescence, whenever we can. But yeah,
eventually, if we need to refactor, we need to make some changes which are breaking, right?
Yeah.
What about pragmas and obsolescence and obsolete code? So
there's a couple of things
let's
there.
Let's talk a bit about that. Yeah. I know it's something that's close to your heart.
When we started with these obsolescence, very quickly we realized that we were doing a lot of it, and at some point we were going to have to clean this up, and we were actually building a mountain of debt ahead of us that we could see growing, and
because we weren't actually removing it, or
no, because we were obsoleting, knowing that in 2 versions we're going to have to remove this code, but we had no process of doing it. So somebody would have to go in manually, find all these places and remove that code. So that's when we started using the preprocessor symbols. So we can, it's a very useful compiler tool, right? So we add these symbols, so we can at the time of obsolescence say, this is the old code, and when we clean it up, this is what the new code is going to look like.
Without actually removing it, but
without
can compile
removing it.
And the compiler look at it as if it was removed, right?
And so we compile our app in 2 ways. So we compile with the old code that's currently being shipped, and we also compile a version with the preprocessor symbols enabled. So that's the new code, and we make sure that both work. So that removes a lot of the debt, right? Because we do it at the moment of obsolescence. We don't push it in front of it. But then we also have an automated process that parses the source code and removes the old code.
So that's done automatically.
So it's done automatically. So we're no longer pushing this mountain of debt ahead of us. We operate on a zero debt principle. So if you want to change some code today, you have to make sure that when you check that in, there is no extra work after
In
the
2 years
check-in.
from now, that
Exactly.
everybody will have forgotten about. Yeah.
So the next step in that story, which is so we obsoleted tables and fields on the which relates to the SQL schema, and we couldn't change the SQL schema. So that was fine, right? They would just live on forever. But now, a couple of years later, we have way too many of them and it's starting to clutter the code. So we've decided that every 5th release, we're going to clean up the SQL schema. So that's good. We can go do that. But we don't
That's
want
roughly every 2 years or something like that. Right?
2.5 years.
2.5 years.
Yeah.
Yeah.
So if we removed a field in this release, we don't want to delete it the next release, right? So we need to know, have these fields been removed long enough? And so now again, we have the same situation where we have this debt because we have fields that were obsoleted in version 15 that are still there, but we also have fields obsoleted in version 25, and we don't want to remove those yet. So we're now introducing a new preprocessor symbol, which you call clean schema, which is, so we add those symbols so that we can use the same automated process to clean this up. And the debt we have is we have to go add all these symbols to where we have these removed tables
we didn't
and
do it
fields.
from the beginning.
Exactly.
Yeah.
So, we learn as we go, then we fix it. So in version 26 now that we're working on right now, we will do this cleanup. And from then on, it'll be an automated process. And so partners will know several releases ahead of time, like, hey, this
What's
field
coming.
that they stopped using, it's actually going away in a couple of releases.
So what do you say the end goal is with this whole componentization effort? When I don't want to ask when will it be done because we will be done because it's a bit hard to say. But what's the end goal?
Componentization, it has many different aspects, right? So we want smaller apps that have one purpose because they're easier to understand, they're easier to use. We document them so that partners don't have to know 6,000 objects. They can look at the API of a module, know what it does, know what it's used for, and know how to use it. So we want to do that for all of our code. Also, at some point, once everything is componentized, I think it would be very nice if we could have the components actually be replaceable so that partners come in with their own version of a given component and just swap it out. We're not there yet.
So they could have their own HR module, for example, or
Yes.
that would be. I don't think anybody is going to replace the finance module.
I don't know.
That seems ambitious, but okay, why not? Why not?
Wait, sorry. Very long term. We are part of the bigger Dynamics family, right? And we have, Dynamics for sales, we have finance app, we have, operations app. So you might have companies that are very heavily finance focused that might need a very heavy finance operations kind of, deal there, but they don't need very much of the others, and maybe BC is a better fit. I think it's more common to be the other way around. You use BC for finance and then have a dynamic sales app.
Right.
And that, if it was truly modular and we could combine those in the distant future, I think that would be truly powerful.
Or maybe also maybe there's a future where we could not install all these modules. Have more lean apps. So like if you're on a specific installation at a specific customer, if they don't need HR module, inventory module, or supply chain management, pick your combination. You would only install the modules that you need, and then all the events don't get fired. You probably. I'm not saying we will get better performance, but we will get certainly reduced footprint in terms of memory and
it will be very good on many levels. So users wouldn't see actions or pages that they don't need, that they don't use.
The UI would be a lot leaner as well.
UI would be leaner. There will be less code to run, less code to manage. So I think it would be very good in many different ways. Also, partners wouldn't have to consider so many side effects if they knew, like, hey, for this customer, they're only going to have these features installed. You no longer need to worry about the others. Whereas now, those features are there. Their code does interact. So you do need to worry what the side effects is going to be on those features, even though the customer is not going to use them. So I think that would be very nice.
Yeah. All right.
Yeah.
Well, that's I think good conclusion. Well, that's what a little bit about our app and the architecture of it. And I hope you enjoy this episode. Thank you for watching.